Alright, similar polygons. Alright, so similar figures are figures or shapes. I would say they're that are the same but not the same size. And the way we use the symbol for similar figures is the little squiggly uh, without the little equal sign. So this means similar. All right? Two shapes that are the same, but they're not the same size. For example, I can have a big rectangle. I can have a small rectangle. They're both rectangles, but they're not congruent. But they're similar because they're the same shape. However, they're not the same size. So these guys are similar. Yeah. And there's uh, in terms of similar polygons, uh, in order to label something as similar, so to label something as similar polygons, yeah. They all have to have congruent corresponding angles. So corresponding angles must be congruent. All right, that's one condition. Second condition, and this is all about ratios and proportions. Corresponding sides are proportional. Okay. Corresponding angles must be congruent. Corresponding sides are proportional. So here they give us two shapes. I'm not going to write them like them. I'll just do it like the two rectangles because it's going to be easier. So A, B, C, D. These guys are all 90. G, H, G, H, I, J. Another itty bitty rectangle. Also 90 degrees. The corresponding angles are congruent. So we're told that figure ABCD is congruent to figure GHIJ. Yeah, so angle A congruent to angle G. Angle B is congruent to angle H. Angle C is congruent to angle I. And angle D is congruent to angle J. But not only that, their corresponding sides are proportional. So let's call this big. Let's call that small. So we're going to do proportions from big in the numerator and a small corresponding side in the denominator. So on the left hand side we have AB. Its corresponding side is HG. That's going to be equal to BC up top and its corresponding side HI. CD on the right over IJ on the bottom, AD on top, and then GJ. Alright, these guys are all proportion. That's one extended proportion. All of the proportions are going to be the same. That is a similar polygon. And again, this is called an extended proportion. We have, we said a proportion is two fractions that are equal. In this case, we can have more than two. So two or more proportions that are equal is called an extended proportion. When we do find out what that proportion is, we call that the scale factor of the proportion. So here they give us two polygons. Okay. If we're going from big to small, we can say AB over XY, which is equal to BC over YZ, which is equal to AC over XC. I could pick any one of these. So let's do AB over XY, which is, why did I say AY? Which is 15 over 6. I'm going to simplify this fraction, divide top and bottom by 3, and I get 5 over 2. This guy is the scale factor. It's just basically the simplified ratio. It's 5 over 2, or you can write it as 5 to 2, or you can write it as 5 to 2. Alright. That's the scale factor from big to small. We can also have the scale factor from small to big. And that's just the reciprocal. So if it's 5 to 2 from big to small, from small to big, it's going to be 2 over 5. And that would be the reciprocal. These guys are reciprocals of each other. So depending, and what happens is the problem is going to specifically ask you which one it is. So here, it says the scale factor from ABC to XYZ. So from big to small, the scale factor would be 5 to 2. They will specifically ask you in the problem, well, what is the scale factor from blah, blah, blah to blah, blah, blah. Alright. Here we have these two triangles. MPN. We have a bigger triangle. Nah, does it a bit better. TRS. They want to know what the congruent angles are. So they tell you that triangle M and P is similar. Write this shit down here. They tell you the triangle MMP is similar to triangle SRT. So we can, since they already told us they're similar, they're already aligned. So M is congruent to angle M is congruent to angle S. Oh, wait. I'm dodo butt. Wait. Start over. Alright, I'm going to use this one. So we have D, E, F, G. We're told that that shape is similar to H, J, K, L. Okay. Now, we can draw this. If you guys can't see it, you can do a visual and just say D is first here, so I'm just going to put it here. E is second, I'm going to put it here. F is third, I'm going to put it here. G is that. I'm going to do the same thing over here. H, J, K, L. If it helps you to draw a picture, by all means. Angle E is congruent to angle. I'll start with D first. First. Angle D is congruent to angle H. Angle E is congruent to angle J. Angle F is congruent to angle K. And angle G is congruent to angle L. So those are the corresponding congruent angles, and they want their extended proportion. So just looking at the picture, I'm going to go from this to this. So ED is over JH. EF is over JK. FG is over KL. And DG is over LHL. Alright, that's my extended proportion. From big to small, and then if you did it from small to big, it would be the reciprocal. And this would also be true. So the other way would be GH over ED, JK over EF. And again, it depends on what this problem is specifically asking you to do, either from big to small or small to big. Dictates which one goes in the numerator and which one goes in the denominator. But I think it's important to see both extended ratios because these are equally true. And they don't really tell you which from which to which. They just say corresponding sides. Maybe it means from here to here. Who knows? Okay. Are these guys similar? We have this guy. They're all 90 degrees, so all the angles are congruent. So let's see if they are. The extended proportion is equal. So if we go from small to big, we have KL, and its corresponding side is WX, and that should be equal to KN over XY. Well, we could say WZ. Since it's a rectangle, if this is 15, that's 15. So this is 10 over 20, which is 1/2. And then over here we have 15 over 15, which is 1. So 1/2 does not equal 1 over 1, so they are not similar. They are not similar. Their extended ratios are not congruent, or their ratios are not congruent, are not proportional. Alright, so we have these two shapes. These two guys are 90, these two guys are 90, A and D. Their corresponding side, S and U, they're congruent, and then E and T are corresponding sides. So all the angles are the same, so that works. So Let's do an extended ratio. Let's go from big to small. We go AB over, and it's going to flip it this way, RS. That should be equal to BC over RV. And that should be equal to DC over VU. Why do they always put V and U next to each other? I don't understand that. That always annoys me. ED over TU. And AE over ST. Alright, so 18 over 9, which is 2. 18 over 9, which is 2. Nice. 18 over 9, which is 2. 12 over 6, which is 2. And 12 over 6, which is 2. So they're all 2 from big to small. So since they're all 2, these are similar. So yes. They want to find the value of x. I believe they tell me that they're similar. So I know that they're similar. So that means that corresponding sides are proportional. So x, if we go from big to small, and we set up our proportion, BC is corresponding side. Oh wait, they want us to find y. So AB over EF. And if we look over here, the big side here is AD. That should be equal to AD over the small one is ED. Alright, so that's our proportion. So we just substitute. AB is 5. EF is Y. AD is 9. ED is 6. So we're going to cross multiply. 6 times 5 is 30. Divide by 9. Which is what? 9 goes into 33 times with a remainder of 3, which is 3 1/3. So 3 1/3 is going to give me y, or you could write 3.3 blah. Okay. And that makes sense because if we look here, the scale factor is 2/3. No, 3/2, which is 1 1/2. So that makes sense. So if we was to divide by 3 1/3, yep, we get 1.5. So we're good. All right. Alright, so we have a post design, and I guess we're supposed to fill up a wall. Of posters to sort of fill up the wall proportionally. Our poster dimensions is 6 inches by 10 inches. And it's 6 inches height and 10 inches width. All right. We also want to fill up a wall that's 3 feet high by 4 feet wide. First things first is we got to put these guys in the same units. So 3 feet is 36 inches, 3 times 12. And 4 feet is 48 inches, 4 times 12. All right, by doing that, we can set up our proportion from wall to poster if you wanted to. So wall over poster. And the way that we're going to set this up is that we're going to do this by the height of the wall and the height of the poster. So we got the pick one that I can go into evenly. So we're going to select the 6 because 6 can go into 36 evenly. 6 can go into 48 evenly. 10 not so much. So we'll select 6 for my dimensions. Which would make the most sense. So this is going to be for the wall 36 inches in height over 6 inches in height. That's going to give me 48 inches in width, and then we have to find what that guy is for it to fit. So this is going to be 36 x equals to 48 times 6, which is 288. Divide both sides by 36. And I get that x is equal to 8. Inches. Alright, so our poster is going to be, the largest the poster is going to be is 6 inches by 80 inches. Or did I set this up wrong? I might have set this up wrong. I think we're looking for how big the wall is going to be out of 10. So I think it's this way. So it's going to be 360. 6x equals 360. I'm sorry. X equals 60 inches. So what they're asking you is how big of the poster can you make that's going to fit that wall? And the biggest poster that you can make that's going to fit that wall, it's going to be 36 inches by 60 inches. or you can say it of 3 feet by 5 feet. That's the dimensions of it. Okay. So the way that this is going to work is we're setting up our proportion. I chose 6 because 6 can go evenly into 48 and 36. Wall to poster, we keep the dimensions of the poster because we're trying to find out the wall, how big the poster can be to fit into the wall. And the biggest that it can be is a factor of 6 and not a factor of 10. All right. So that's that. The last thing we're going to talk about is scale drawings, which is the same thing as using sort of like a scale factor. So scale drawing is just a picture that's a representation of a real life model, or the model is a representation of a real life figure. A scale is to me the same thing as a scale factor. The only difference between scales and scale factors is that the units doesn't have to be the same. Units doesn't have to be the same. So scale is the ratio or fraction that compares the drawing to the real thing. Whatever that may be. Here we have a drawing of the Golden Gate. Here the scale is 1 centimeter to 200 meters. So 1 centimeter on this drawing is representative of 200 meters on the bridge. So here it says the scale drawing in problem 5 was the actual height of the towers above the roadway. What, do you want me to use a ruler or something? The length of the span of the scale drawing is 6.4 centimeters. Let S represent the span of the bridge. Well, if I knew what the height of the tower was, then I can easily set this up. But I don't know what the height of the tower is. No, unless I'm missing something. Well, if I was to set this up, I have 1 centimeter over 200 meters. If I knew what the height of the thing is, so here's the length of the bridge here. They say that the length is 6.4 centimeters. I'll just make an educated guess. If this is 6.4, half of that's 3.2. Half of that, 1 point. Let's just throw for argument's sake that the height is equal to, I don't know, a quarter, 2/10, 0.2 centimeters. Let's say 1 centimeter. 1.5 centimeters. So then we were right, since this is the drawing would go up here. So 1.5 and then over x. So r squared would be from the drawing over the actual. So we cross multiply. So x equals say 300 meters. That's if I was given a number. I don't know what the tower is. I have no idea what the actual height of the tower is. Do they even give me that? Anyways. Okay, and that's how you would do those types of problems. You set up your actual drawing over your actual, cross multiply, solve for the problem. Okay. Alright. That is that section. Hope you have a great rest of your day.